Alright, and these are going to be the video notes for lesson 5-7 over the Pythagorean Theorem. Most of this lesson will seem very familiar to you. As you guys know, a squared plus b squared equals c squared, but we will go a little bit more in depth with this. So why don't you begin by doing a warm-up, these 4 problems in your note packet, and when you are ready, we will continue. Pause the video if you need more time. Alright, here are the answers we should get, classifying each of these triangles by measure. 80 degrees, 70 degrees. The third angle, sorry about that, the third angle there would be 30 degrees, so that would be an acute triangle. In this triangle, we have a right angle given, so we know it is a right triangle. And to simplify this, you might remember back when we worked with simplifying radicals, you're going to square 2 and square root 3. 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. And lastly, if a is 6 and b is 7 and c is 12, a squared plus b squared would be 85. C squared is 144. Which value is greater? C squared would be greater than a squared plus b squared. 144 is greater than 85. Alright, today's objective will be to use the Pythagorean Theorem and its converse to solve problems. And we'll look at what the converse is in just a little bit. We will also use what are called Pythagorean inequalities to classify triangles as either acute, obtuse, or right. We'll talk about what a Pythagorean triple is a little bit later on. But first, let's remember this about our Pythagorean Theorem, and it's given to you in the notes. Okay, if we have a right triangle with side lengths a and b for the legs and c for the hypotenuse, then you remember that a squared plus b squared equals c squared. But we have to know that it is a right triangle first. We have to have that given information, then we can conclude this. So in example 1a, let's find the value of x using that. So we are going to set up our Pythagorean theorem, a squared plus b squared equals c squared. But then we're going to make some substitutions. For a, we're going to substitute x minus 2. Writing it like this is very important. For b, we can substitute 4, and for c, we can substitute x. These two pieces aren't that difficult, but this part is a little tricky if you don't remember to use FOIL. Remember, x minus 2 squared is the same as x minus 2 in parentheses times x minus 2 in parentheses. In that case, we would have to use FOIL. So when I simplify this, x times x is x squared, x times negative 2 is negative 2x, x times negative 2 again is negative 2x, so those combine to negative 4x, and negative 2 times negative 2 is positive 4. So using FOIL and simplifying, we get this. Then 4 squared is 16, and x squared remains x squared. Now we can combine like terms. 4 and 16 gives us 20. When I subtract x squared from both sides, that gets rid of the x squared, so it's no longer quite as complicated. We get negative 4x plus 20 equals 0. So if we add 4x to both sides, 4x equals 20. Or you could subtract 20 from both sides, but then we have negatives on both sides. Dividing both sides by 4, we still get x equals 5, or 5 equals x. So the value of x is 5. Alright, we're going to set up something very similar here. To find the value of x, we're going to plug into our Pythagorean theorem. X for a, 12 for b, and x plus 4 for c. Remember, you have to FOIL this right-hand side of the equation. On the left-hand side, you still get x squared plus 144. On the right-hand side, you get x squared plus 8x plus 16. So in subtracting x squared from both sides and subtracting 16 from both sides, we get 8x equals 128. Divide both sides by 8, and x equals 16. Alright, as we move on to example 2a, you'll notice there is no diagram given to you in your notes, and so we cannot actually do 2a. There's nothing to do there. Just put an x through that part of it, and we will move right on to do example 2b. Alright, so here's example 2b. Randy is building a rectangular picture frame. I've gone ahead and given you a little bit of a diagram here. Why don't you draw that in on your own notes as we read through this. He wants the ratio of the length to the width to be 3 to 1. That means he wants the length to be 3 times as long as the width. And he wants the diagonal to be 12 centimeters. So how wide should the frame be? So we're looking for the width of the frame rounded to the nearest tenth of a centimeter. So we're going to let L and W represent the length and width in centimeters. So L is the length, W is the width. But if that ratio is to be 3 to 1, I can express the length in terms of the width. So I can call the length 3W instead of calling it L. Well, that gives me an expression for width and length all using the same variable, so I don't have two different variables needing to do a system of equations. We don't have to do that when we just use W and 3W for those dimensions. And remember, the diagonal should be 12. So I've gone ahead and drawn that here for you again in the top right. We're going to call the width W and the length 3W. Pythagorean theorem is going to be used because when I place that diagonal, I get a right triangle here, where this L equals 3W could be the width or the length measurement down here along this side, like this. So we can see that one leg of our right triangle is called W, the other leg is called 3W. So I can make some substitutions. Remember, the diagonal is supposed to be 12 centimeters, so we can substitute 12 for C. So 3W squared plus W squared equals 12 squared. Now all we have to do are square 3 and W together, square W here, and set that equal to 144. 3W squared is 9W squared when you square both, plus W squared gives you 10W squared. So the first thing we should do now is divide by 10 on both sides. So W squared is 144 over 10, or 14.4. Now, we are told to find the positive square root and round to the nearest tenth. Now, they do the square root in this picture of the fraction, but if you use the decimal and then rounded it in your calculator, that's okay. You're still going to get about 3.8 centimeters for the width, which is what we were asked to find. So the width of his picture frame needs to be about 3.8 centimeters. All right, moving right along, a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared is called a Pythagorean triple. And you're going to start to notice some of these as we go on. Here are the first 4 most common Pythagorean triples: 3, 4, and 5, or any multiples of 3, 4, and 5, like 6, 8, and 10, or 9, 12, and 15 would also be a Pythagorean triple. 5, 12, and 13, or any multiples of those. 8, 15, and 17, or any multiples of those. 7, 24, and 25, or any multiples of those. These are not all the Pythagorean triples you could come up with. You'll notice some more as we go through these lessons, but these are some of the most common ones. So you'll start to recognize these as we go. So for example 3a, we want to identify Pythagorean triples. We want to find the missing side length and tell if the side lengths form a Pythagorean triple. So let's take a look at how we should begin. To find the missing side length, we use our Pythagorean theorem because we know it is a right triangle. So we substitute 14 for A and 48 for B, and we find out what C equals. 2500 equals C squared. If I take the square root of both sides, C is 50. Since A and B are both integers, 14 and 48 are integers, and C is also an exact integer, the side lengths are non-zero whole numbers that satisfy the equation, so they form a Pythagorean triple. All right, let's take a look at what the converse of the Pythagorean theorem gives you. It tells of a way to tell if a triangle is a right triangle when you know the side lengths. And so the Pythagorean converse, or converse of the Pythagorean theorem, we are given the 3 side lengths. If they satisfy this equation, then we can conclude triangle ABC is a right triangle. All right, so this is the part you actually need to write in your notes. You've given everything else here, but you need to write in the conclusion in this red box. If we know the side lengths of a triangle and they do satisfy this equation, meaning they make it true, then we can conclude it's a right triangle. If not, if a squared plus b squared does not equal c squared, then it's not a right triangle. All right, the Pythagorean inequalities theorem is based on that converse. If a squared plus b squared does not equal c squared, then c squared could be greater than the sum of these two. In that case, c is actually extended. If c squared is greater than a squared plus b squared, notice how I've flipped the Pythagorean theorem around. It's not a squared plus b squared on the left and c squared on the right. We're starting with the hypotenuse side on the left, and it has to be written this way. If the hypotenuse squared is more than the sum of the other two sides, then we're extending that hypotenuse longer, making this angle bigger than 90 degrees, so it's an obtuse triangle. If c squared is less than a squared plus b squared, we have shortened that hypotenuse, making the angle at c smaller than 90, so it's an acute triangle. All right, here's an explanation of that again. I'll let you read through that as I'm talking through it. If c squared equals a squared plus b squared, then it's a right triangle, because c would have to equal 90 degrees. If c squared is greater than a squared plus b squared, remember, put the c value on the left and the other two on the right this time, then it's an obtuse triangle for greater than 90, greater than, greater than. But if c squared is less than 90, if c squared is less than a squared plus b squared, then it's an acute triangle because that angle measure is less than 90 degrees. Less than, less than. This only works if you set up c squared on the left and a squared and b squared on the right. By the triangle inequality theorem, the sum of any two side lengths of a triangle is greater than the third side length. We learned that in lesson 5.5. So in example 4, we're going to classify these triangles as either acute, obtuse, or right, but first we have to tell if they are in fact side lengths of a triangle. If they can be side lengths of a triangle, then we can classify. Step 1, determine the measures if the measures form a triangle. Remember, that means the sum of any two must be greater than the third. By the triangle inequality theorem, 5, 7, and 10 can be the side lengths of a triangle because 5 plus 7 is 12, that's greater than 10. 5 plus 10 is 15, that's greater than 7. 7 plus 10 is 17, that's greater than 5. Step 2 is now to classify that triangle. So we're going to compare c squared to a squared and b squared. C has to be the greatest side. So we're going to substitute the longest side for c. So 10 squared equals 5 squared plus 7 squared. Again, there's a question mark there because I'm not sure if that's true or not. 10 squared is 100. 5 squared is 25. 7 squared is 49. 25 plus 49, is that more than 100 or less than 100? 74. That means c squared is greater than a squared plus b squared. 100 is greater than 74. So this must be an angle measure greater than 90, so the triangle is obtuse. Let's try example 4b, using 5, 8, and 17. The first thing we should do is make sure that these actually form sides of a triangle. If two sides add up to more than the third side, then it does form a triangle. So that's our first step. But if we add 5 and 8, we recognize that's 13, which is not greater than 17. So these cannot be sides of a triangle. Since they cannot be sides of a triangle, we cannot classify any triangle. So we are done after we've determined that these cannot be sides of a triangle. So you'll notice we have a lesson quiz again. There's a few problems here. Pause the video and try and work them out, and then check your answers. Okay, if you've taken time to do these, here are the answers you should have gotten. Number 1, x is 12. That works out a lot like example 1 from earlier in the notes. Number 2 is going to work out a lot like example 2. Yes, the TV with the 60-inch diagonal will fit in because 65.6 is greater than 60. Here's the next two problems for your lesson quiz. If you need more time, pause the video. All right. If you are ready to check your answers for both of these, here's what you should get. The other side is 13. 5, 12, and 13 do form a Pythagorean triple. And number 4, tell if these can be side lengths of a triangle. If so, is it acute, obtuse, or right? 7 plus 11 is greater than 15. 11 plus 15 is greater than 7. And 7 plus 15 is greater than 11. So it does form a triangle. And when I add these two and square 2 squared, 15 squared is still greater